All right, hello everyone, and welcome to a lesson on section 6.4. This section deals with parallel and perpendicular lines. And let me just bring your attention to one thing very, very important. You are missing one handout in your group of handouts for this. So I have this handout if you need it. So if you're watching this video, the next time you're in class, I will get this handout to you. If you have a printer at home, I will attach it. You'll see this in the EDSB post. You'll see the attachment and you can print it out. So one handout is missing, not the first one, but the second one. So we're going to go through parallel perpendicular, a little experiment. You'll have the back side of a handout to do. This is the one that some of you will be missing. And a couple textbook questions, all right, all dealing with parallel and perpendicular lines. So let's get into it here. Investigation number one. This is on parallel perpendicular. It says graph each set of lines on the same grid. So we're starting to get good at graphing. And let me start with this line right here, 2x minus 3, or y equals 2x minus 3. We're learning that in order to graph these, we start at our y-intercept, which is -3, way down here. And then what we're going to do, I'm just going to make this a little bit bigger. Right there, so all right, so our y-intercept is right here, and now we're going to use our slope, which is 2 or 2 over 1. Rise and run. So in order to not mess up our graph as much, now that we know how to graph, from here I go up 2, 1, 2, and over 1, put a point. Up 1, 2, over 1, put a point. Up 1, 2, over 1, put a point. I was just doing rise and run without having to put my triangle. I grab my line tool, I put a line through, and this is the line 2x minus 3 right here. So this is the first one, and I will go like this to show that that is this line right there. 2x plus 1. When we graph this one, we put a point, and I'll just go like this. We put a point at our y-intercept, which in this case is plus 1 right there. Our slope is 2 or 2 over 1, so up 2 over 1, up 2 over 1. I put a line through it. I'll use this one right here. We put a line through. And we get a line that looks like this, and that is going to be this one right there. Okay, so we can see our two lines on this graph. We'll get to the relationship in a second. The next one, let's graph both of these. So in order to graph this, pause the video even and try this on your own, and then come back and see if you did it right. But when you come back, hopefully you saw that plus 4 is your y-intercept. You go down 1 over 2, put a point. Down 1 over 2, put a point. Down 1 over 2, put a point. I'm just not showing the two lines, but I'm moving down 1 and over 2. Rise and run. We put our line through. Looks something like this. And we have our first line, which is this equation right there. Okay. We go to graph our second line, and we go, whoa, wait a second. This is not in the form y equals mx plus b, or y equals mx plus b, or y equals mx plus b. This is in standard form. So what we need to do is we need to take this line and we need to put it into slope y-intercept form. I did this over here. Here's my equation right here. I started by getting the 2y by itself. I moved the x and the 2 over, and then I divided by 2. Divide this by 2, divide 2 by 2. Now it's in slope y-intercept form. So when I graph this, I'll use red. I go down to -1, down 1 over 2, down 1 over 2, down 1 over 2, and we get this line right here. This is this line. Okay. So we have these two sets of lines, and when you're looking at these, you're probably starting to come up with what you see here. First question, how are the lines in each set related geometrically? When we look at them on a graph, how are they related? I think most of you will look and say they're heading in the same direction. We call that parallel, okay? How are the equations related? Okay, now we go back up to the equations. How are these two equations related? How are these two equations related? And what I want you to notice is, do you see the slope? And you see the slope? Those are the same. Do you see the slope here? And although we can't get the slope from this equation, we put it into y equals mx plus b. Do you see the slope here? The slopes are actually the same. That's what makes them parallel. The slopes are the same. Doesn't matter about the y-intercepts. How can you tell whether two lines are parallel given their equations? Well, when you look at their equations, make sure they're in slope y-intercept form, y equals mx plus b, and then just see if their slopes are in fact the same. Okay, do they have the same slopes? If they're equal, they're parallel. If they're not equal, they're not parallel. So the equation, or give the equation of two lines parallel to this, all you need to do is make sure that you have 3x. Okay, so y equals 3x plus 2 or y equals 3x, those are perpendicular. Or sorry, parallel. Those are parallel. So parallel lines have the same slope, and we show it with these two little arrows. So back up here, oh, I might have went too quick here. Those two arrows, this one and this one, show that two lines are parallel. So up here, after you know that they're parallel, you might be able to take your pen and you might be able to just go over here and say, okay, little arrow on this one and a little arrow on this one. These are parallel. Little arrow on this one and a little arrow on this one. These are parallel. Okay, so first investigation, parallel lines. You can graph each of these, okay, graph them here, pause the video, come back, you'll see how they're done, and then we'll talk about them. Welcome back. So for here, minus 4, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I put a bunch of points there, and I can say that this is my line right here. The next one, I'll use red. So y-intercept is positive 1. Down 1 over 2. Oh, they share a point. Down 1 over 2, down 1 over 2. So I put a bunch of points there, and this is my red line. Okay, not quite sure here. Let's go over to this. Start with green. Positive 3. Down 2 over 3. Down 2 over 1, 2, 3. Put a point. Down 2 over 1, 2, 3. Put a point. And you get this line right here. And we get our first line in green. Okay. Next, we graph this one. Once again, I take a look at that, and our problem is the fact that this is not in the form y equals mx plus b. So I put it into y equals mx plus b. You can do that, but I moved the 2y over. I divided everything by 2. Notice the 8 went to 4 and 3 gets divided by 2. And then I just put the y in front. So I just have to graph this line right here. So I grab my red. I start at negative 4. Slope is 3 over 2. So up 1, 2, 3 over 1, 2. Put a point. Up 1, 2, 3 over 1, 2. Put a point. Up 1, 2, 3 over 1, 2. Put a point. All of those are in the same line. So I now graph this. I go all the way here. And that is this line right here, which is actually this line here. They're the same. Okay? So now, how are these lines related geometrically? These are definitely not parallel. But if you take a look, I believe that these meet at a right angle, 90 degrees. 90 degrees. And that's called perpendicular. They intersect at a 90-degree angle. Okay. How are the equations related? All right. The slopes are what we're looking at again, but these slopes are not the same. These slopes are not the same, but there is a trick. If you were to take this slope and flip it, put the -2 on the bottom and put the 3 on the top, and then change the sign. That negative becomes positive, you get 3 over 2. If you flip these two, 2 over -1, change the negative. You get 2 or 2 over 1. Okay? So, this is called a negative reciprocal. You take your slope. If it's a negative, you make it a positive. If it's a positive, you make it a negative. You switch the sign, and then you also flip the fraction. So slopes that are negative reciprocals. So for example, 3 over 4 and -4 over 3. Those are perpendicular slopes. 3 and -1/3. Remember that 3 is like 3 over 1. Flip it, change the sign. 1 over 2 and -2, or -2 over 1. Those are perpendicular. They're called negative reciprocals. Next, how can you tell whether two lines are perpendicular given their equations? Well, just look at their equations and look at their slopes and see if they're negative reciprocals. So, give the equation of two lines perpendicular to y equals 3 over 5x plus 2. 3 over 5 is our slope. We have to flip it and change our sign. As long as your line has this as your slope, it's perpendicular. So I went -5 over 3x plus 2 and -5 over 3x, no y-intercept, 0. So at the bottom, you can flip your number and change the sign. That's called a negative reciprocal. So -2, you flip it, so it becomes 1 over -2, change the sign, just 1 over 2. Negative reciprocal. So that's the investigation. So here's all you need to know. Parallel lines have the same slopes. They're the same. Perpendicular lines have negative reciprocals as slopes. It means flip, change your sign. Okay? So hopefully you got that investigation done. Now, here's the handout that you guys do not have. I've attached it in Edsby so you can print it out if you've got a printer at home, or the next time in your class I will get this to you. But it explains parallel and perpendicular lines, how you can see them with roads. A lot of cities have parallel roads and then perpendicular roads that go across them. They meet at 90-degree angles. Parallel lines. Two lines are parallel if their slopes are the same. Make sure your lines are in y equals mx plus b. If they're not, it's hard to tell. So for example 1, here's my first line, here's my second. We see that our slopes in both are 2. These are parallel. Here, example 2, -3 over 4 and, oh, wait a second. This is in y equals mx plus b, so we have to do a little work. Move the 3 and the 8 over. Change their signs and divide by 4. Now take a look at their slopes. Now they're both in y equals mx plus b. These are parallel. Okay? We use little arrows to show two lines being parallel. Perpendicular lines, though. Two lines are perpendicular if their slopes are negative reciprocals. Okay? Make sure they're in y equals mx plus b. And please note, negative reciprocal means flip the number, the fraction, and change the sign. So when you take a look at these two equations, this slope is easy to see. -1 over 2. This is 2 over 1. Do you see how you flip this and change the sign? These are perpendicular. Over here, -0.5 and, oh, wait a second. This is not in the form y equals mx plus b. So here, I brought the 4x and the 12 over. You could have brought the 2y over by itself and did what we did up here. That's fine. Okay, brought the 2y over, but I just kept it here. I moved the 4x and the 12, and I divided everything by -2. And then that gives me 2x minus 6. Now, -1/2. You have to do a little work here. -0.5x is -1/2. That's the fractional form. Now this is the fractional form of this one, and you see how they're negative reciprocals. It's hard to compare a decimal and an integer, so I put them both as fractions. -1 over 2 fraction and 2 over 1 fraction. Now I can compare these two. These are negative reciprocals, which means these two lines are perpendicular. Okay? So on the back, here's what I'd like for you to do now. Okay, this is the handout that you're to complete. Answer these two multiple choice questions, parallel, perpendicular. Question 2, here are two slopes. Are these parallel, perpendicular, or neither? Here are two slopes, parallel, perpendicular, or neither. Go all the way through. If they're the same slope or the same value, then they're parallel. If you flip it and change the sign, they're perpendicular. And if neither of those work, then it's neither. Next, here are 1, 2, 3, 4, 5, 6 equations. Make sure you put them in slope y-intercept form. This is in slope y-intercept form. This is not. This is not. Put those in slope y-intercept form. These both are, believe it or not. There's just the special cases, the perpendicular, sorry, the horizontal and the vertical lines. Okay, go back in your notes, you'll see what these two are. And then once you get the form here, then state what is a slope parallel to this line, what is a slope perpendicular. And then to get a little practice on intercepts, 6.3, that's all this is. Section 6.3, practice these two. Find the intercepts and graph them, and then maybe ask about, see if the relationship here, see if you can find out what the relationship is. So that's the handout you're going to do. We'll take that up in class. So that is this handout right here that I asked you to do, the backside. These questions in the textbook, and we will take up any issues with that next time you're in class. I am going to be posting a video with some solutions to some of this homework, so stay tuned for that. But stay good, everyone. See you guys very soon. Parallel, perpendicular lines.